Good morning, college. Today we are going to solve exercise 331 of the book Fundamentals of Electrical Circuits Sadiku. This exercise tells me to find the node voltages of the circuit in the figure. They already give it to us marked, which is V1, V2, V3E. Obviously there will be three equations with three unknowns. Well, let's look at what we have to do first. The first thing I observe here is this source of dependent tension. We know that it is located within two nodes. This is what is called a supernode. This is as if we had a point in common, that is, how we pretend that there is a short there when we do this visual analysis of the currents. This current of 1 ampere comes from here and arrives here. From here you have to take your way to different sides. This current reaches here. I say that one part comes here through this resistance and the other part comes here. This polarity that says more, minus B0 is what tells me or gives me a clue that the current must come from here. That current passes through here and is going to reach this point. When it reaches this point, well, a part goes here. We know that they no longer give it, that it is in sub-zero n. And the other part comes here, which is twice V sub-zero as a dependent source. The current, when we get to this point, let's remember that all of this is a node, since a part will go here. And what else is missing? That resistance. This source of tension points me upward. Therefore, I say that the current will take that direction, right? Let it reach this point and it will join with it and release up to two currents. Now having the currents previously marked, I am going to give a name. I'm going to call this and 1. I'm even going to call it Y2 and I'm even going to call it I3. I'm even going to call it N4 to the same. 1 that is here and 4. Okay, let's start with the analysis. Node V1 on node V1. Well, let's remember that this is a super node. This would be node V1 and node V2. And V2. Let's look at what comes and goes from this point. And this point is connected to this point. If this is all a single point, we have to look at what goes in and out of that point. Let's put what comes in here. Here we see that the current of 1 ampere enters. Enter here. If I'm going to mark all of this is the same point. Concept of nodes. Then the current of 1 ampere enters that point. So I say what goes in there is an ampere. And we observe that this also enters all that point, that is plus 2 times P sub 0. This current source is twice P sub 0. I have to put it like this. All of that is going to be the same as what comes out of that point. What comes out of the current. And we know that all that, what I had previously marked, that I am going to leave it marked if I don't like it, scratched in case I have to scratch more. What comes out there is N1. More the other thing that comes out of there is N2 and the other thing that comes out there is N1 and 2 comes out of there and 4. We can now do the stress analysis. So 1 plus 2 times V sub 0 will equal the current, and 1 would be the voltage V1 over 4 V1 over 4 the current, and 2 V2 over 1. It is 2 over 1 for the current and 4 for the voltage that is coming out of this point. Let's remember that although I called all this a node, does not mean that the force on the 4 is versus 1 plus V2 would not be versus 1. The tension of this point minus versus 3, why not versus 2? This is a super node, but we still have to find an equation to complete it. We'll see it now. So the current I4 comes out of V1 minus V3. About 1. Okay, let's go there. Let's notice that, well, I'm going to write here 1 plus 2 times V sub 0. But what is V sub 0? V sub 0. The voltage that falls on this resistance. I'm going to do it here. Part 5. Sub 0 is what a voltage is like, and that voltage is what falls here. So how do I determine that voltage? Well, you should have more practice later, but we're going to do it right. The attention that falls here is V1 minus V3 over the ohm. This is the current I4. If that is the current that passes through here, it is this V1 minus V3 over 1. But to determine the voltage here, I multiply it by V1. Therefore, VV0 is equal to AP1 minus versus. When they have more practice, they will simply see that the current comes in this direction. So you are going to say V1 minus V3. Then you say V1 minus V3, and that's it. That's all. Okay, so 1 plus 2 times V1 minus V3. We do this because as we are working with V1, V2, V3, we are not working with variable versus 0. Since we have to replace versus 0 because in terms of V1, V2, or V3 it does not matter the same as a V1. Same a V1 over 4. Plus versus 2, you're not going to put the 1 V2 over 1. It's still V2 plus V1 minus V3. If you remove that 1 there, it's nothing, right? Well, I'm going to download this here. Hey, we're still here. It would be 1 more. 1 plus 2 times V1 minus 2 times V3 equals AV1. Let's remember that this is VV1 over 4 plus V2 plus V1 again minus V3. If I organize, let's speed it up. I organize the variables on one side of the equal and the constants on the other side. The equation is going to be 3 times versus 1 minus 4 times V2 minus 4 times versus 3 equal to minus 4. You can corroborate it yourselves. I'm skipping that algebra part to not make the video so long. I'm going to delete this and let's plot now at node V3. What enters is equal to what exits, or what enters the node V3 is the current enters, and 4 if and 4 the current enters, and 3 equals 2 times 0, right? From that point this comes out and this comes out. What if sub-0? More in sub-0. Well, this part is going to be a little long for us. Current 4 is V1 minus V3 over 1. V1 minus V3 over 1. But I'm going to remove the 1 to speed up the algebra. Plus the current 3, the current, and 310 minus V3. Minus 3 out of 2. 10 minus V3 over 2. That's going to be the same. That's going to be equal to 2 times V sub 0 twice V sub 0. But we had already said that 0 is this, since as we already have practice, it is V1 minus V3. Plus I sub 0 in sub 0. The current coming through here is V3 over 4. Okay, we started working on the algebra V1 minus V3 plus 10 over 2 minus V 3 over 2. It is equal to 2 times V1 minus 2 times B3e plus B3 over 4. Okay. I'm going to leave everything that has variables on one side, as well as anything that has a constant on the other side of the equal. And that's going to look like, please do it yourself. At this rate it's just adding and subtracting, but due to time constraints I can't do it. Here, since there is only variable v1 and v3, that will be minus 4. v1 plus 0 in v2. Look, here there is no v2 plus v3 equals minus 20. That's going to be my second equation. Now, since there are three variables, I'm going to save that first here. There are three variables of 2. Here are two equations with three unknowns. I need a third equation. It is always taken from the supernode. How can we get that out? Well, we can do that or by taking out an LVK. I'm going to note it here. I'm going to do it in red. We can do a LVK here or we could do a LVK here. Obviously, it's easier for me this way. If I replace this resistance with its terms in voltage, we know that V1, that is, this voltage V1 is the voltage between this point and ground, that is, here is V1. It means that in this resistance there is a voltage of V1 equal to that in this current source, that is, the voltage here is the same voltage here which is equal to V1. V2 is the same. V2, between this point and ground there is a voltage V2. Therefore I can make a separate circuit. Remember that with more practice you can do it directly, in which I replace this resistor with a source called V1. I say that here it is V1. If this resistance I am removing it by its equivalent in voltage, because if in theory we knew the voltage, here we do not need the resistance between here and V1. Between here and here there is a dependent source. The dependent source that less more is 4 times and 0. And here I am going to put another source. I'm going to do it what is called V2. Why are the polarities that way? Because of the direction of the currents. The current in one goes like it goes down. Here it is more polarized, less. That's why I put more less here and here too. I also wrote down the current for more less. So if I do the LVK here, the LVK, I notice that minus V1 would be minus V1 minus 4 times and 0 plus versus 2. This is being equal to 0. Kirchhoff's voltage law now minus V1 minus 4 times and 0. But in 0 and 0 is the one that comes here, which would be in parentheses versus 3 over 4, that would be Y0 plus V2 equals 0 volts. So EH, with this it goes, and in the end I am left with the equation minus V1 minus V. Well, here is plus minus V1 is this. I'm going to put V2 first to coincide here, plus V2 and V3, which is negative, would be minus V3. All of that is going to be equal to 0. This would be my third equation. I'm going to delete this and let's watch. I'm going to put this into MATLAB. Let's open MATLAB. Good, huh? The first equation was 3 space, first row minus 4, space minus 4, semicolon. The second was -4, space 0, space 1 semicolon, and the other -1 space 1b space -1. Again for v it would be -4 semicolon. We go to the next row, which is -20. Semicolon and 0. We check 3 -4 -4 volts 3 -4 -4 -401 -401 -11 -1 Ready? -4 20 0 -4 -20 and 0. We solve the solution variable equal to a against the verses. And here are the values 4.96484 and -012. I'm going to put here V1 is equal to 4.96 versus 2 times 4.84 and V3 is equal to -0.12. Ready? We verify that the exercise asks us, it asks us for the tensions. Then we corroborate. Ready? This is where the exercise